Hi. After Democritus, Aristotle, Boyle, Dalton, and Thomson, now we talk about what Rutherford did to create an atomic model. Rutherford conducted a very important experiment that revealed a lot about the atomic structure. This experiment is called the gold foil experiment, and sometimes it's called the Geiger-Marsden experiment. Why three names of three scientists? It's simple, because Geiger and Marsden conducted this experiment under the supervision of Rutherford. It was a team effort. Rutherford was experimenting on radioactivity, and he was studying the alpha particles, so he designed an apparatus for that. In this experiment, he put a piece of radium inside a lead box with one small hole to force the alpha particles to move in a specific direction. He also put in front of this small hole a very thin gold foil. But why the gold foil? Actually, because gold is the most malleable metal, and he wanted the thin foil to be as thin as it can be. Then he surrounded the gold foil with a screen detector, a piece of metal which its inner walls are coated with fluorescent material to glow when the alpha particles hit it. This is how the apparatus looked like. When you shoot alpha particles through a very thin gold foil, it's like when you shoot a bullet on a tissue paper. You would expect for all the alpha particles to go in a straight line. Examine the picture carefully. What do you see? Exactly. Most of the alpha particles did move in a straight line, but this was not the strange thing. What's strange is that a small number of alpha particles deflected after passing through the gold foil. Also, a small number of alpha particles reflected as if they didn't pass through the gold foil. But how did Rutherford explain his observations? Examine this picture. This is how Rutherford explained his observations. If most of the alpha particles penetrated the gold foil and moved in a straight line, then most of the atom is space. And if some alpha particles changed their direction after penetrating the gold foil, then they must have come close to a tiny dense particle that carry the same charge as the alpha particles, the positive charge. And if some alpha particles could not penetrate the gold foil and they were reflected, then they must have hit this positively dense particle that was called later the nucleus. Now, Rutherford is ready to explain his atomic model. According to Rutherford, the atom is extremely small. It has a complicated structure that resembles the planets, electrons, rotating around the sun, which is the nucleus in this case. The nucleus is even smaller than the atom. It carries a positive charge and it's in the center of the atom. Electrons have a very small mass that can be neglected, and electrons move around the nucleus. Remember, the amount of negative charge must equal to the amount of positive charge to make the atom neutral. That's it for today. See you soon.